Okay. Damn it. I want this to be professional, and what haven't I done yet on the board yet?
Fix the date.
Fix the date. There goes my professionalism. But we got to keep this, what is it? We have to keep this real, so we have to keep all the screw-ups on here. Okay, so your job yesterday centered around this picture. We were projecting something from the ground. We were just gonna, we gave you the velocity that you're gonna project it at, so everybody had the same velocity, but each group was given a different angle. And those were 15, 30, 45, 60, 75, and 90. And you were supposed to figure out 3 things about the flight of that object. 1, how long does it stay in the air before it comes back to the ground? 2, what is its range, which is how far does it travel horizontally before it hits the ground? And then 3, what is the maximum height, which we call delta y max? Now, I mentioned that there were different ways that you could go about finding these 3 things. So everything you needed was over here in these equations, but you could go through this in a different order and still end up with the correct answers. So I don't know, were there any groups where one person said, okay, this was my methodology, and someone else said, well, I got those answers, but I didn't solve it that way. I went in a different order. If that was the case, that is totally legitimate, because what it comes down to is, what do you see in this picture? Now, there was one key spot, and I can't remember if we had this specific discussion or not, about this spot right there. What was special about that spot at the delta y max?
Vy is 0.
Correct. So we would say Vy equals 0 meters per second there, because at the maximum spot, you're not going to go up any higher, but you haven't started to come back down yet. Okay? Now, depending on whether you were looking at the first half or the second half, this 0 meters per second could be an initial y velocity or a final y velocity. Now, I'll go ahead and point out one other thing. Over here, we said one thing that you had to be comfortable with is, we called this Vx and this y. See, there's another blooper. And technically this was VIY because this was its initial projection. Did anybody, oh, I wonder if it picked up my phone mic too.
So many bloopers.
Yeah, that's what's going to make this interesting. There was something else that you could have done that related to the end of the problem. Did anybody even go to the end of the problem? Okay, I'll do this, I'll match the colors here. When this thing hits the ground, guess what angle that is? It's the same as theta. And if we look at this, again, this is why I wanted you guys to just become comfortable with vector stuff. I need to extend this. I didn't draw this the best. A little bit more shallow. How does this Vx here compare with this Vx there? It is the same, because Vx horizontally, we are doing constant velocity. how does, and most people would call this VFY because it's at the end right before it hits the ground. How does that VFY compare to this VIY?
It's negative.
It's the same but opposite. Now, what is the only, this is another kind of conceptual question. What's the only reason in this picture that we can kind of make, for example, the connection about the angles and then the connections about the VYs?
It's on a flat ground.
Correct. So, in the big picture of this overall flight of the object, what is the delta y total for this if we look at the entirety of the trajectory?
0.
It's 0.
4 for 4.
Because it starts at the same level, or it finishes at the same level that it starts at. So when we are going to be doing some, I'll call them shortcuts here, some of those shortcuts, if you use them, you could only use them because of this. If we were doing a problem where we said, look, you're going to take a ball and you're going to throw it up to somebody like who's on a roof. It's not that you can't use some of these principles, but overall, that trajectory does not look like this. So you're a little bit more restricted about certain, making certain associations or assumptions. And the same applies for if you were the person on the roof and you were tossing something down to somebody on the ground, because then your delta y would not be 0. Okay? So in math, one of the things about this particular situation, key word that's beautiful in math, symmetry. The first half of this trajectory and the second half are like mirror images of each other with some twists. So this idea that this VIY and this VFY, they're the same value, but they are opposite signs. It's the vector nature of those triangle breakdowns that tell you that. Okay? So if you saw some of those connections, you could maybe choose some equations that were a little bit easier to deal with to get certain values. But you can only go with what you see and understand in the picture. Okay? So I'm going to leave that, that was your kind of personal path that you go through. If you were to ask me, how would I go through this? I would say, overall, delta y, this is stupid to put overall here, but I'm trying to emphasize this. If I look, I would approach this first in its entirety and say, look, my delta y is 0. I'm going to go right here, and I'm going to find the time. Because if I have 0 equals 1/2 ay t squared plus viy t, if this equals 0, I know that this is negative 9.8 meters per second squared, and I know this VIY would be 20 times the sine of whatever angle I'm projecting at. But mathematically, what I can do is I can factor out a t, and I get 1/2 ay t plus vi y. Now, who remembers from your algebra 2 what's nice about this setup right here? What would I do next if I was going to solve for my t?
Well, you could, I don't want to say disregard, but you don't need to pay attention to the t in front of the parentheses.
Okay. And then what would you do then?
So you do 0 equals 1/2 ay
Right.
plus vi.
The idea is that I have a times b equals 0. What must be true then? One of them 0. So either a is 0 or b is 0. So that's the justification for your comment about disregarding the t. Either one of these could be 0. So now I can come over here and go 0 equals 1/2 ay t plus viy. Now, if I solve this for t, I would bring the VIY over by subtraction, and then I would have to divide by 1/2 AY, and I have that. Now, does anybody know why this is like super cool compared to actually putting numbers in there? Let me simplify one thing. What does the 1/2 become if someone goes, I don't like that 1/2 in the denominator?
2VI.
It becomes 2VI. So this would become negative 2VIY over AY equals T. Nobody's connecting with this. We haven't used any numbers, have we? So if I developed this before you ever started, how many groups could use this? All of you. Because this is an equation, not a calculation. So if you know how to break this into Vx and VIY, all of you could have used this. Now, is this the only way that you could find T? No. Okay? So did anybody go for delta Y max first? You did? Okay. So you went down here and said, oh, well, if I, and that's where you connected with, it's 0 up here, so that meant your final Y velocity was 0. You knew what this was, and you knew what this was, so you could figure out that. Then you could go to another equation to get your T. You still end up with the same thing. Now, let's say I do that first. There's my T. I'm good to go. I think the next thing I would go for is this, because it's just simple. Now that I have my T, I come over here and I go, well, if Vx equals delta x over t, and I just finished finding my t, and I want to find my delta x, I can just rearrange this to that, and again, I have an equation. All of you could have done this. What was the last thing I needed to get? My delta y max. If I was going to go for one, what would be an easy one? I'd probably go here. Now, here's the key thing. If I went here and said delta y max my VIY was whatever I have here, what would my VFY be?
Whatever you have at the end.
If I'm right here,
Oh.
it would be 0. And does somebody want to highlight, I don't have this completely correct yet. There's a detail. Has to do with this. How far am I through my flight to get there? Half. So what would I have to do with my t here if this is the equation that I'm choosing? I'd have to divide this by 2. So this would be 1/2 t from up there. But again, I have not put a single number in any of this. So if I did this before you guys, I sent you out, this is why I didn't do that, y'all would have just done this. Hopefully you had to grapple a little bit with what was going on, and you had to choose. What the hell equation do we want to start with? And different people could choose different things. Now the thing about this that's super cool that I'm going to show you at the end that I kind of threw out earlier, because this is all equation based now, I can make a spreadsheet off of this and just tell the spreadsheet, do this in certain cells, and then just put beginning values in, and it just dumps everything in there. Because it's doing the same processing over and over and over again. The only thing that changes is this triangle at the beginning of the problem, depending on what angle you are projecting at. So I'm going to show you that towards the end here. Damn, this is good. All right, so I'm going to erase all of this. And now, okay, who's my group 1 person? All right, Reese, this is what I want you to do. You are going to trace the trajectory of your object at your angle.
Okay.
So you can see that horizontally I have laid out a scale. So everybody is starting right here. Here is your vertical scale. Okay? So, yeah, come up here.
All right.
Your
Put in
angle
the
was
numbers.
15.
Yeah.
So you're using black.
Okay. Am I
So-
putting in the values too?
Yes, put the values in there first. And I want to say you can. Did everybody go to at least the nearest hundredth? So like round at the nearest hundredth, because if you had a whole, okay, that's fine.
Oh, I did too much.
That's fine.
Oh boy.
Just as long as you didn't like keep going on and on and on.
Should I do 100 for this one?
Whatever. I'm, okay, so that's your starting point. So what you need to do is go to your ending point, and then you need to kind of find the middle, and then you need to go up the appropriate thing, and then draw your curve. And don't worry if it's really bad, we'll do it. Okay, perfect. All right.
Oh yeah.
All right, who's group 2? All right, Matthew, you're doing exactly the same thing. You're doing red. Okay, so don't worry about making a red X. We know we're just starting there at the X. So locate your delta X, which is where it would have ended up hitting the ground. And then that you can make a little mark there. Okay? Then you got to find your delta Y max, which happened in the middle. So if you went a total of just over 40, you'd be going just past 20, and then you got to find maybe a little. Okay, that's fine. Now you got to try and make a parabola that.
Shoot.
Okay, that's all right.
Matthew's gotta get it perfect.
Let's call Matthew second.
Matthew.
Okay.
Okay.
Very good.
This is gonna be good.
Okay,
Okay.
no
that
problem.
worked.
The big deal is the overall picture. Okay, you're good.
Yeah.
Good job.
Nice job. Okay, group 3. You guys are getting the idea, right?
Good luck, Nick.
Saint.
Your posture's really good.
It really is.
I'm gonna have to check my master list. Okay, now you gotta.
Oh.
Now hold on. No. Just step aside for a moment.
Oh no.
Nate, you're sending for a straight up.
Hey, Nick, you're not alone,
Okay. I got one problem from the last group.
Yikes.
Okay. Let's see, what did we have for T? 2.04. I'm okay with this. I got a problem with this. So, group 2, this is what I want to know. What is your Vx value that you have? This goes back to this here.
Oh, shoot.
What's your Vx value?
I did wrong.
Okay, what did you have for your Vx?
I put the wrong value, but 17.32.
Okay.
I put 20 on accident.
Okay, so hurry and make your correction there. And come up and make the correction here. So you go ahead and finish yours. Okay.
Did he?
I don't know. Did anybody as Nick was putting his numbers up start to go, oh, that's kind of weird.
Yeah.
What was the thing that you were going? I don't know if that's right.
The delta x is
The fact that you had the two different angles, but the delta x's were the same. That's okay. Yeah, keep going. Good. Okay. There we go. All right. So, Matthew, come up and redraw your red one. Yeah, make the correction on your delta x, and then redraw.
Second time is
What second time's a charm, and 3 strikes and you're out if we had.
and he plays baseball, so it makes sense.
Oh. Now, this is not going to be a huge change. Okay. Wow, now that-
That was a good one.
that's good. Okay, excellent. Okay,
Incredible.
Come back.
Wonderful job.
Wonderful.
next.
Boy, Andrew.
Yes, Andrew.
Good luck out there, Andrew.
Andrew
Thanks,
is
Reese,
always
I
a
did
lift
it.
during AP Calc.
Oh.
Now I'm going to have you change one thing on the left. Bring it into this because this is where
Oh,
everything's going. So just
okay.
take that half. See, this is where if we like edited this, people, wow, everything came out perfect. It's like that's not the way stuff really works.
Isn't it the truth?
Okay, that's fine. Okay, nice. All right, next group.
That's for last. That's for last.
Oh,
Oh.
not a good start.
Now, what is it? Well, I'll wait till all the numbers get up there.
Ooh, that green one. What is the true value?
Okay, that's fine.
Nice.
Okay?
Yeah.
All right. Now, last one. Our time of flight. Our delta X. And our H max.
He gave himself the best one.
All right. So this one. Mine's easy. Okay. Now, this is a classic trajectory picture regardless of what your speed was. We could have changed this to whatever we wanted, and if we went through this progression of these angles, the only thing that would change would be what our scales are. But this generic picture would stay pretty much identical. Now, I want to highlight a couple things.
It's not really hard. Yeah.
Where's it coming from?
She figured out it. She watched me do it. McKenna.
Okay. If we were doing this as a lab, now we would say, tell me what you see, like patterns. What patterns can you establish in all of this crap that's up here? There are a few, but just give me one. Okay, Andrew?
The 30 and 60 degree angles have the same delta X.
Okay, 30 and 60 seem to have a similar value, as do 15 and 75. Okay. Is their trajectory identical? No. But this, like, how far did they go is the same. Yeah, we'll go ahead and do this. I'm going to draw some pictures. I'm going to be off camera here. There's my 20. And I'm trying to do 15. There's 30. I gotta try and make this the same length. Yeah, it's not the greatest. I think this might have to be a little bit shallower to be 15. $45. I'm really going to town on this one. 60.
Oh,
75. My orange. And then my 90 pretty much would be like this. And it would be all this. Okay? So, Andrew pointed out the 30 and the 60, went the same distance horizontally, but they did different things through the air. Why? When you look at this picture and you go from here to here, the black arrow is the same all the time. It's 20. What's happening to your Vx as you go from 15 to 30 to 45 to 60 to 75? It's getting shorter. But while that's happening, what else is happening? The vertical is getting bigger and bigger. This thing here, I love going through this, because when someone says, make it go further, what's the ultimate in distance?
45?
45. And if someone says, make it go further, and you're already at 45, what's your only solution if you need it to go further? You have to figure out how to make that thing go faster then. And when someone says, why is it that you end up losing delta x when you go away from 45?
You're essentially trading off height for, like, if you change to make the delta x will be a trade-off to delta y.
Correct.
45 is like the equal in between.
Correct. So the idea is your velocity, if you cannot change it, locks you in. And when you say, I'm going to change my angle, you're doing this trade-off thing. Well, if you make it a steeper angle, I'm going to lose Vx for the sake of Vy. And when you do that, what changes about your trajectory? Instead of going low, you end up going higher. Okay? Now, look at the red and the green. Why the hell would I want one or the other? They both went the same length. Let me give you a couple sports things. Now, this assumes you know the sport we're talking about. Baseball or softball? You're an outfielder. You're trying to throw the runner out at home. You need to go 35 meters. You going 30 or you going 60?
30.
Why are you going 30?
Less time.
Not the faster, because you're still throwing at the same speed. You're doing it to save time. Now, when someone goes, why did you save time? At 30 degrees, what dimension are you emphasizing in your velocity? The horizontal, which is going to get it there quicker. Football, you're going to punt. 30 or 60?
60.
Why 60?
More time in the air.
And what does that do for you? It lets your players get down the field. So in football, could punters punt much further than they do in games? Absolutely. But they would end up outdistancing their own team, and that would give the other team more time to actually coordinate some kind of a run back. So punters in football favor higher angle trajectories, not because of a delta X issue, but because of a T issue. Projectile, let's say you're launching something, this is like medieval times. You got to launch something into the city. What are you probably going to have to launch it over? A wall. So you're probably going to favor a higher angle, not because of a time there, but because of a delta Y max. Because you got to clear something in order for it to get where you want it to go. This crap's awesome. Okay? So it all comes down, though, to these pictures here and this idea You go in one dimension, it comes at the expense of the other dimension. Unless you could just say, I can throw it faster, which in this case we were not allowing you to do. Okay, hopefully this was a little interesting for you.
This was a good video. Like, I wish I wasn't here today so I could watch this video.